my dear students, prep 3. My topic today is about unit 2, lesson 2, electric current and cells. In the last session, the first lesson, we will talk about the electric current. Now we will talk the different types of electric current. We have two main types, direct electric current and alternating electric current. We will compare between them according to these items. The first item, sources. The sources of direct electric current, electrochemical cells. What is the meaning of the electrochemical cells? Electrochemical cells like dry cells and battery. Dry cells and battery which change chemical energy into electric energy. Okay? But alternating electric current related to electric generators. Electric generators. What is the main idea of electric generators? Electric generators change mechanical or kinetic energy into electric energy. Okay? Like dynamo. Now we will talk about intensity. In direct electric current, intensity is constant. What is the meaning of constant? Not variable. But alternating electric current are variable. Variable means different, change, but constant, the same intensity at all the time. Direction, in direct electric current, unidirectional. Unidirectional also has constant direction, one direction. But in alternating electric current, different directions. Maybe opposite directions also. Okay? So the main items in the direct and alternating electric currents, intensity and direction. We can define the direct electric current. It is the current which has the constant intensity and unidirectional. But alternating electric current, it is the current which has variable intensity and different directions. Transference. Direct electric current transfer for short distance. But alternating electric current transfer to long distance. Okay. Direct electric current can't transfer or can't change into electric alternating current, which can write AC. But alternating electric current, if we fix the intensity and direction, we can call it direct current. So it can change into direct current. Uses. We can use direct electric current in electroplating or generating some appliance or some devices. Some devices which need amount of electricity or electric current small. But alternating electric current can generate electric powered stations and most of appliances. Okay? The last item, graphical representation. Direct current has constant current intensity. So current intensity at the time pass doesn't change. But alternating electric current, the electric current increase, decrease, increase, decrease. It is variable. It may be constant at some times. So we prefer alternating current intensity more than direct current intensity. Why? Because I can control its direction and amount of intensity. It used to generate electric powered stations and most of electric appliances. So electric current, alternating current preferable than direct current. Now we'll talk about the methods of connection. In grade 6, we talk about methods of connecting cells in electric current. We have two main methods, series and parallel. Series means the electric batteries connected side of each other. Negative, positive, negative, positive, negative, positive. So the current intensity distributed in all these cells. Cell number 1, cell number 2, cell number 3. If the electric current pass, so it distributed along the 3A cells. In parallel connection, they are parallel to each other. So we connect the all negative poles with each other and all positive poles with each other and connect it by the battery. So the electric current pass not distributed along the 3 cells. They are passed on the cells as the same of each other. So it's the branched roots. What is the difference also between series and parallel connection? In the last session, we talked about potential difference and EMF. Let's remember the difference between potential difference and EMF. Potential difference, it is the potential difference, it is the difference between the potential terminals between cell 1 and cell 2. It is the difference between two terminals, okay, when the electric circuit is open, is closed. EMF, it is the potential difference when the electric circuit is open. So potential difference closed. So the electric current pass through it. When the electric circuit is open, we calculate EMF as no current pass. So, to calculate electromotive force in series connection and in parallel connection. In parallel connection, E battery equal E1. Why? All of them are equal. And the current intensity branched in 3 roots, but it has the same value. If in cell 1, E, for example, equal 3 volt, so 3 volt, so 3 volt. So E battery equal 3 volts. But now we have 2 types. In series connections, we have different cells or similar cells. Maybe in series connection, maybe they are 3, 4, 5 volts, and maybe all of them have the same value. If they are different, we will take the sum of each of them as the electric current intensity distributed along the 3 cells. So E battery equal E1 plus E2 equal plus E3. But if they have the same value, we write EP equal N times E1. What is the meaning of N? N, the number of cells. So I have 3 cells times the amount of battery, or EMF of the battery, times 3 equal 9. Is it easy? Now we will solve some problems in المعاصر school book as a training. Page 155. Notebook, homework, answer worksheet 4 in your booklet, in your soft copy of booklet. Okay, page 155 in معاصر, problem 21. In this problem, look at this figure. if the quantity of electricity which passes through the opposite electric circuit in a time equal 40 seconds in 20 coulomb, find the ammeter reading. I. Find the EMF of the battery. Find the resistance of wire R knowing the reading of the voltmeter equal 1.5 volts. Okay, we need to remember the relations that we had taken in the last session. I equal Q divide T, V equal W divide Q, R equal V divide E. So the first needed items, ammeter, I equal what? I equal Q divide T. We have Q, yes. We have Q equal 20 coulomb divide 40 seconds. So equal 0.5 ampere. We need to calculate the EMF of the battery. We must look at this figure. Is this connection series or parallel? I think it's parallel. Okay, so EMF of the battery equal E1, one of them. So one of them equal 1.5 volt. Like if it's series, we must make the summation of each of them. Okay. Another needed items, the resistance of the wire. We need to calculate I when the reading of voltmeter equal 1.5 volt. To calculate R, we must have potential difference and electric current intensity. I have potential difference and also I have electric current intensity. So we will substitute R equal V divide R. 1.5 divide 0.5 will equal 1.5 divide 3 ohm. Again, in any problem, you should write the rule, substitute, write the results and units. Each step is so important. Okay. To solve problem 22, it has a tricky given. In the opposite electric circuit, if the EMF of each cell equals 1.5 volt and the value of the resistance equal 3 ohm, when the circuit is closed, calculate the EMF of the battery. When the circuit is closed, EMF equal 0. Why? EMF, it is the potential difference when the electric current is open, when the electric circuit is open. So EMF closed circuit equals 0. But to calculate it when the circuit is open. Now we have series connection and parallel connection. Each one have 1.5. Okay. So they are parallel and EMF of the battery. Remember, EMF battery equal EMF series plus EMF parallel. If we don't have series, so EMF battery equal EMF parallel. If we don't have parallel, equal series. But if we have series and parallel, we must calculate both of them. Okay? So now we have parallel and series. The parallel equal only 1.5. But the series, we will take the summation of each sum. So it equal 1.5 plus 1.5 plus 1.5 equal 6 volts. Is it easy? Now we need to calculate the reading of the ammeter. The reading of the ammeter when the electric circuit is closed, not open. So if the potential difference equal 1.5 volt and the resistance equal 3 ohm, we can calculate the reading of the ammeter. Why? Yes. Why? I can get it from this rule or this rule. I think we don't have time and quantity of electricity, so I can calculate I from this rule. I have resistance equal 3 ohm and I have V equal 1.5. So I equal V divide R. V equal 1.5 divide 3. Calculate it in your calculator. 1.5 1.5 divide 3 equal 0.5 ampere. Is it easy? I think this is enough in this session. In another session, I will complete and we will do more exercises about this lesson. Please study well and answer the homework. If you don't to ask about any questions, you can ask me. Thanks a lot and have a nice day.